Okay, we are going to now model with quadratic functions. We learned how to graph them. Okay, now we're going to model with them. Okay, so a pool company offers rectangular pool size with dimensions as shown. Each pool includes a deck around it. If Caroline wants a 15-foot wide pool with a deck, how many square feet will she need to have available in her yard? Okay, so let's just review. Square feet, what that means is area. Okay, can somebody remind me what area is? Yeah. Base times height or length times width. Okay, so our area is length times width. So we need to identify the length and the width here. So we look at the pool. It says the deck is 4 feet wide. So that means this piece right here is also 4 feet. That also means that this piece right here is 4 feet. So this entire length here is x plus 4 is 8. Does that make sense? Then this width is 2x, but we want the whole length from here to here. So again, this is 4, and this is 4. So that's 2x. 4 plus 4 is 8 plus 8. Any questions over that? So write a quadratic function to represent the area of the pool deck. So the quadratic function is going to be the area. That's all it is. So I'm going to have my area equals the length, which was x plus 8, times the width, which was 2x plus 8. Okay, to multiply two binomials, we draw the box. And do x plus 8, and then 2x plus 8, and multiply. X times x is, sorry, x times x is x squared, and then 2 times 1 is 2x squared. Then 8 times 2 is 16x. Then x times 8 is 8x. And 8 times 8 is 64. I almost said 16, not 16. Okay, so I get the area equals 2x squared. 16 and 8 is 24x plus 64. Okay, so that is a quadratic function that represents the area of my pool and my deck together. Any questions over that? Okay. In B, they say find the area of the pool if the pool is 15 feet wide with a deck of 4 feet. Okay, we already have the deck of 4 feet. We want to know, what it's asking me here is what happens if x, the width, is 15, and the x is represented for the width. Okay, so we just plug it into our equation. We have A equals 2 times 15 squared plus 24 times the 15 plus 64. So we have A equals 15 squared is 225. 24 times 15 is 360 plus 64. Then 225 times 2 is 450 plus 360 plus 64. So 4 and 0 and 0 is 4. 6 and 6 is 12 plus 5 is 17. So it's 874 feet squared. Okay, so if the length of, or if the pool is 15 feet wide, then the total area of the pool and the deck is going to be 874 feet squared. Any questions over that? We're all good? Yes. So the deck is already included because remember we added in to the length and the width, the 4 and the 4, the 4. Since we added it into the total area, the dimensions of the pool, we don't have to add anything else to the area. Okay. Any other questions? Okay, I'm going to have you guys do the next one. Now they're going to change something up a little bit. Okay, now suppose the length of the pool in example 1 is 3 times the width. In example 1, you had the length being twice as big as the width. So now they're just going to change that 2 to a 3. So now this is 3x from here to here. You still have the 4 feet here and the 4 feet here. Okay. Find now the area of that deck. And this is still x. Okay, so you guys do that problem. Okay, so again, the length of this whole thing is 3x plus 8. The width of this whole thing is x plus 8. Okay, so to find the area, we just multiply the two together. X plus 8 times 3x plus 8. When we multiply that out, we should get 3x squared plus 32x plus 64. Okay. Any questions over that? We're good? Okay, on the back. Okay, vertical motion can be modeled using a quadratic function. Okay. Anyone in physics? No one's in physics here? Okay, well, if you, yeah? Okay, so have you done this yet, vertical motion yet? No? Okay, so eventually you'll get there to determine at what velocity you should be launching things to get a certain height or distance that you want to travel. And this is the formula for vertical motion. It is a quadratic function. Okay, so The number in front of the t is your velocity, initial velocity. Okay, velocity is the initial force in which a ball is thrown or a rocket is launched. Okay, initial height is where it's starting from. Okay, where it's starting from. And h represents the height of the ball in feet. Okay, so the height in feet over the time in seconds. Okay, after t seconds after it's launched into the air. So we're going to try and solve some problems that involve vertical motion. So a diver jumps off a high platform at an initial vertical velocity of 16 feet per second. What quadratic function represents the height of the diver after t seconds of the dive? So they want us to write this equation. The key is we need to start with what they've given us. They've given us the velocity, the initial velocity. So v is equal to 16. The initial height is not given to us in the equation, but we can see it in the picture. What is the initial height? 30 feet. So the initial height, the h, is 30. They just want, what is the quadratic function representing? So they just want the equation. So we're going to write the equation. I'm just going to plug things in. So I have h of t equals negative 16t squared plus the initial velocity of 16 times t plus the initial height of 30. I mean, they make my plus sign look more like a plus sign. Okay, that's all it's asking me that first step is to write the equation. Okay, so then it says, how many feet above the platform will the diver be at the highest point of the dive? What does highest point mean in relation to parabolas? Yeah, the vertex. The highest point in this case is the vertex because it's spaced upside down, right? My parabola is spaced upside down, so the maximum point is going to be the vertex. Okay, so we need to find the vertex. In order to find the vertex, we need to start by finding the axis of symmetry. And that is x equals negative b over 2a. So we review. Okay, the a value is negative 16. The b value is 16. And the c value is 30. Then we plug it in. X equals negative 16 divided by 2 times my a value, which is negative 16. Okay, do the math. Okay, negative 16 divided by negative 32. They can both be divided by 16. Okay. And a negative divided by negative makes that a positive 1 over 2, 1/2. So the axis of symmetry is x equals 1/2. Okay, that is the x value of my vertex. So that means in 1/2 a second is when it's going to reach its maximum. Okay, that's what this is stating. Okay. So what's our maximum point? We have to plug it in. Okay, so we're going to plug in 1/2 for x and then solve. I'm going to do that over here so I have more room. So I have f of 1/2 equals negative 16 times 1/2 squared. Times 16 plus 16 times 1/2, then plus 30. Okay, so f of 1/2 equals 1/2 squared. 1 times 1 is 1. 2 times 2 is 4, so it's 1/4. Half of 16 is 8 plus 30. Then again, when you guys deal with fractions, this is not scary. Okay, fractions just mean division. So it's 16 divided by 4. 4, right? So it's negative 4 plus 8 plus 30, sorry. So f of 1/2 is equal to 34. This is feet. Okay. Okay. So let's review what it's asking me for. How many feet above the platform? How high is the platform? 30 feet. Okay. Am I 34 feet above the platform? No. How many feet above the platform am I? 4 feet. Okay. Because this is my total height from the ground. I just want above it, above the platform. So we're going to write that. Since the platform is at 30 feet, is 4 feet platform. And that's my answer. Any questions over that? Okay, the next one. My equation, h of t equals negative 16t squared. plus 8t plus 20. Is that correct? Yes. Okay. Most of us got our axis of symmetry of being 1/4. Correct? Okay. Then we plug it in. H of t equals negative 16 times 1/4 squared plus 8 times 1/4 plus 20. 1/4 squared is 1/16, not 1/8. 1/4 of 8, or 8 divided by 4 is 2. This will be -1. Sorry, this is 20. -1 plus 2 plus 20. So h of t. Oopsie, I shouldn't have a t there. I should have 1/4 equals 21, right? Okay, and it asked me what is the maximum height above the water. So how many feet above the water am I? 21 feet, right? So I'm 21 feet above the water. Any questions over that? Okay, what does it mean in the real world situation when the initial velocity is zero? And find the error. Find the error. I'm having issues reading right now. Okay, you do those two right now. Okay, this one is really tricky. What does it mean in the real world situation when the initial velocity is 0? Yeah. Okay. Would I have a problem if something wasn't moving? No. Okay. So yes, we wouldn't even have a velocity problem if something was standing still, right? So you need a velocity problem that would have an initial velocity of 0. So let's review what initial velocity is. The initial velocity is the velocity of an object before acceleration causes change. Okay. So if I have an initial velocity of 0, what's another thing that could be occurring? What? Okay, so again, velocity is how hard I throw something, yes? Well, that would be like no motion, right? Okay, so it's not going to be no motion. Yep. I'm dropping something. Okay, it's falling off, okay, my desk. Something fell off the desk. Okay, if I had it in the air and I just let go of it. Okay, I'm dropping something. That's what initial velocity is 0. Okay, when I drop it, acceleration is automatically going to speed it up now, and it's going to hit the floor at some speed. But I'm not throwing it. Okay, I'm not jumping and then dropping. Okay, let's write that down. Okay, could someone come up with the error? What happened here? Yep. Very good. They switched the two numbers. Okay. To determine the height of the ball seconds after it's thrown at the initial velocity of 16. So it should be h of t should equal negative 16t squared plus 16t plus 6. They switched these two. So write down something like that. Okay. Any questions over that? And make sure you wrote down that it gets dropped. Any questions over that? Okay, homework.